Welcome everyone to today's webinar on microservices, the new building blocks of financial technology, co-hosted by Quantifi and Celent. My name is Sakvir Chima, Director of Marketing at Quantifi. Today's webinar will be presented by Marc Adler, Chief Architect at Quantifi, and Cubillas, emerging regulations, market unease, and internal pressures heightening the attention on risk, technology and operations. The second part will be presented by Marc, who will highlight innovation in risk technology, in particular smart evolution, utilization and deployment towards microservices. At the end of the webinar, you will have an opportunity to post questions using the panel to the right of your screen. If we don't have time to answer all questions, we will provide an email response to your question. I will now hand you over to Cubillas.
Thank you, Satwir, and greetings to you all. Now, I know that some of you already know us, but for those unfamiliar with Celent, we are a research and advisory firm focused on financial services. So we cover areas of banking, insurance, and capital markets, where we publish industry reports and conduct market insight studies in the intersection of a business strategy and operations around areas such as technology enablement, innovation, and emerging best practices. Now, for my section today, I will be sharing perspectives around risk management and regulatory trends and some of its pressures on how firms manage operations and technology. And Marc from Quantifi will present to you some of the emerging technology approaches in the form of microservices, architectures that can serve as an enabler to better understand and address the needs of firms that are undergoing some of these changes ahead. So let me start off by saying that the combined impact of the global regulatory reform agenda since the last financial crisis continues to have a significant impact on the financial sector as a whole. The banking sector in particular has taken out a quarter of their balance sheet capacity, 10 to 15, yet many global banks are still not achieving targets and hence are bracing themselves for further balance sheet shrinkages and cost cutting in the next few years. Now, and so as we gaze into the near to middle term horizon, we expect the cumulative impact of existing overlaps showing here. These are not both its velocity of some changes ahead. What you have here is an illustrative schematic of various activities and processes in 4 areas, such as in frontline marketing and trading, middle office, counterparty and market risk management, as well as back office accounting and financial control functions in the context of a typical financial institution. And so if we examine this, we see the following areas of impact. First, Basel II and III regulations, credit and counterparty risk measurement, assessment, monitoring, as well as risk capital management. And then there is also the fundamental review of the trading book, FRTB, which requirements for in trading book capital, the introduction of new risk measures, as well as more stringent modeling methodologies and stronger operational controls. Now, overlaid against these, we see that supervisors are focused on requirements such as through be classified and also driving cleared and non-clear trades, which will impact how counterparty is actually done. And for larger systemic institutions, they are also faced with regulatory stress testing and capital assessment exercises on a regular basis, such as in the US with CCAR, with comprehensive capital assessment and review processes, and in that region. And again here, there are shared crossover points and implications in terms of a firm's of being able to forecast various aspects, require firms to forecast on a forward-looking basis credit losses under various states of impairment. And this requires consistency not only within the IFRS accounting framework, but also for firms to have reconciled numbers with some of the regulations that I mentioned previously in order to generate and also project consistent measures for things like valuation, counter different scenarios. And so overall here you see that the interconnectedness of each for integration and consists that a firm's application landscape translates into overlapping systems interfaces, complex data dependencies, and also costly change management issues. And this is shown in the next slide ahead of siloed architectural approaches where the existing challenges such as some of the complex overlapping interfaces, some firms face a landscape of fragmented data repositories and applications, as well as spending significant manual efforts to reconcile different reports around risk analysis, regulatory reporting, as well as some of the accounting and financial disclosure type reports. So I won't cover this in further detail, but just to say that with stringent risk management and regulatory requirements, we believe that further tactical add-ons to existing infrastructure will exacerbate operational complexities, and this will be extremely costly in terms of things like reconciliation efforts. It will increase a firm's vulnerability to potential errors, as well as a lack of auditability of some of the outputs that's generated in firms' reports. And hence, looking into the future, the business case for converging risk and finance data environments has now become more because of, and so in the future we believe that firms will face important choices whether or not to respond strategically to rationalize risk and finance data environments as opposed to continuing to adopt tactical solutions that impose a structural drag on a firm's ability to meet and manage future obligations. So the key question here remains, how does one construct scalable next generation data and building blocks that are flexible and decoupled to address some of the complexities of interdependent overlap? And so with this question, I would like to move on for Marc to take on his section where he will talk through some of the next generation technology approaches that could alleviate some of the pain points which I have mentioned here.
Okay, thanks, Cubillas. Hello, everybody. My name is Marc Adler, and I am going to talk a little bit. I've had a long been at Quantifi for almost a year now. I joined last summer because they have a really great company and are poised to make some incredible impact and improvements in the future. So Quantifi, basically we are a specialist provider of risk analytics and trading. We have offices in a number of countries: London, New York, Frankfurt, Paris, New Jersey, and Sydney. And we have over 140 clients in 16 countries and 5 of the 6 largest global banks. Okay. Okay, so actually do is go over, so Celent has seen complex requirements pose go-to-market integration and consistency theories, and which typically translates into overlapping systems interfaces, complex application, data dependencies, and costly change management issues. So a lot of us who have been involved in large enterprise companies have really experienced firsthand all the silos across organizations and how different organizations keep writing the same code and basically have inconsistencies amongst that code, amongst the data that flows between the code. A lot of effort is spent on reconciling this data and just kind of writing adapters to make things fit together. So what we've seen at Quantifi is everything that Celent has experienced, and we've also just kind of looking back on a lot of the systems that we've used in enterprise applications, which are monolithic applications. Well, we all know that monolithic applications are very difficult to maintain. They have huge code bases and are difficult to test. So imagine that you have large code bases without unit tests, which we've seen a lot of companies have, so it's very difficult to know when you make a change in these monolithic applications whether the system is still operating. And you have the same physical code cutting across logical boundaries. So as an example, we have authorization code that might be scattered among all sorts of different modules. So we might have authorization code in a pricing module, we might have it in reference data module, we might have it in some sort of market data module. So it gets very, very sloppy when you have this kind of physical code across a wide surface area of your code base. And then even with your standard 3-tier applications, everything seems to be very synchronous in nature. You know, somebody who's running a GUI requests a piece of data, it goes to some middle tier. The GUI, you see the hourglass while the middle tier and the server are thinking about how to get the data and retrieving the data, and then you get the data back to the GUI, which is usually displayed in a grid or something like that. Scaling out is difficult with these monolithic applications. Again, you have a very big code base and a very large footprint for an executable that you would have to scale out to different servers and basically plop that entire code down on another server. And then resiliency is also hard with a monolithic application because a crash in a single module might bring down the entire system, and then you have to send a message out that there's an outage. Everybody has to wait until you reboot. So Celent asks an interesting question. How do you construct data, analytical, and architectural building blocks that facilitate information sharing yet are flexible and decoupled to reduce the complexity of interdependent and overlapping requirements? So that's a mouthful, but here comes microservices to the rescue. So many of you have probably heard the term microservices. It's a actually fairly popular term in the industry now, relatively recent. The whole concept of microservices has kind of come about from maybe, or at least been made popular from around 2013, 2014. So it's a software architectural style in which complex applications are composed of small, independent processes communicating with each other using language-agnostic APIs. These services are small, highly decoupled, and focus on doing a small task, facilitating a modular approach to system building. And thanks to Wikipedia for that definition. So we'll dive into exactly what this means. So we've all heard of SOA, or service-oriented architecture, in which systems are composed into kind of big blocks of services. But microservices are the next generation of SOA, where services are a lot smaller in nature and serve single purposes. So services are decoupled and communicate with each other over the network. So a network is a requirement for a microservice architecture, and of course the better the network is, the faster the communication is between these various services. What distinguishes microservices from what you find in SOA is you tend to have smaller, lightweight services. So somebody was actually at a talk the other day at a company called Jet.com which is a new competitor to Amazon that is in New Jersey. And I think Jet.com says they have something like 700 microservices. So that's kind of an extreme of decomposing a lot of little functionality into these kind of smaller, lightweight services. But as we'll see, we have there are benefits with having that kind of architecture. So one of the benefits is that it enables better continuous refactoring and continuous delivery of higher quality components. So with such as, if you have a microservice with such a small surface area of code and its own kind of bevy of unit tests, it's very easy for a team to perform improvements on that particular microservice and deliver it into kind of a microservice ecosystem. And so some of the properties of a microservice architecture is that services are easy to replace. So for instance, if I have a market data service and you don't like it for some reason and you want to replace that market data service with your own kind of microservice, as long as you have the same API and messaging base as that existing service, you could write your own service and easily swap out our microservice and replace it with your own. Services are small and fine-grained, and they perform a single function. So a typical microservice might be a notification microservice whose sole job it is to take a piece of text and route it to different consumers with different kinds of technology. So you might take a message and send it to somebody through SMS, or you might put that message on a message bus, or you might send it through an email. So that is a notification microservice is only designed to do one thing and one thing only, and that is notifications. Or we have a job scheduling microservice in Quantifi whose only mission it is to schedule jobs and run jobs. Each service is elastic, resilient, composable, minimal, and complete. So one of the interesting things that you could do with microservices is that the output of one microservice could be the input into another microservice, and you can construct entire workflow pipelines comprising of different microservices where information just travels from service to service. Services can be implemented using different programming languages, databases, hardware, and software environments, depending on what fits best. So this is an important thing. One of the things that we've seen with other companies that have adopted this microservice approach is that you can have some microservices written in C#, you can have some written in Java, you can have some written in Python, you can have some written in exotic languages like Erlang or Haskell, and as long as you use some sort of interop technology, so some sort of standards, it doesn't really matter what you write your microservices in as long as you can exchange the data between the different services. And then architectures are symmetrical rather than hierarchical. So this is kind of the producer-consumer pattern where all of the microservices kind of sit at the same level of the hierarchy, which is a fairly flat level. And you can have a microservice that's a consumer and also a producer. So there is this very kind of symmetric relationship between microservices. Here's an example architecture that we have with microservices. So for instance, at the top, and this is for incremental XVA, so at the top we have a number of data services. So one is a trade service, one is a market data service, one's collateral, and one's for curves. So each of these microservices on top deal with one and only one domain. So a trade service only knows how to deal with trades. The collateral service only knows how to deal with collateral. So you would find some of your data access patterns embedded within these services, and you'd also find business logic within these services. What happens is, so you have an XVA requester, it could be somebody with the Quantifi GUI, and they make a request for XVA, and the whole processing is very asynchronous in nature. So the request goes along the message bus. That request ends up at the XVA calibration and simulation service, which has gotten all of its constituent data from the various services, from the trade service and market data service and other services. The XVA calibration and simulation service produces asynchronously a result available for aggregation, and also puts the exposures in a database for later use. So the incremental XVA and aggregation service on the right side is subscribing for a notification from the calibration and simulation service as to when the results are ready. So when that incremental XVA service gets that notification, it can get the exposures from the database. It's already loaded up with data from the collateral and curve services. It calculates the incremental XVA, and then when that's ready, it puts a notification on the bus that says, okay, we have the XVA already calculated, and the XVA requester will get that notice and will pull the XVA result off. So this is a very kind of broken up, very asynchronous architecture that is extremely flexible. If you wanted to add your own collateral service or some sort of helpers to the collateral service, it's very easy to do that and either have your own microservice or a helper to the collateral microservice. Okay, so here's how Quantifi has benefited from our use of microservices. So we'll have a faster hotfix and feature release cycle. So because some of our new functionality will just be limited to a certain microservice, it is easy for us to deliver that microservice to a client and have some sort of continuous delivery of the microservices to our clients. Integration with other systems, what we've done is with the microservices and the messaging and the open APIs, we will allow clients to easily integrate their own services within Quantifi. So I talked about how you could make composable pipelines with microservices. So a client could write their own microservice and kind of insert it within that pipeline and perform some of their own customized processing. And also the clients can intermix their own technology with Quantifi. So not all of our clients have developers on staff that are C# experts. A lot of them have Java or Python developers or C++ developers. So if they are comfortable, if our clients are comfortable writing their services in another language, or even run those services on Linux, they can very easily integrate their custom services within our platform. And then it's easy for our clients to scale out. They can locate different microservices on different servers within their organization. They can also load balance between multiple instances of a service. So scaling out is very easy. You could add, you could spin up multiple instances of a certain service, and for instance, ActiveMQ, which is one of the message buses that we use in our microservices, it actually supports scaling out. If you have multiple consumers listening on a single queue, ActiveMQ has certain heuristics where it'll actually round robin requests between the different consumers. And then what you could also do if you needed to is if you have some sort of calculation heavy microservice, you can put it on a more powerful server. So for instance, in one of these kind of public cloud environments like AWS or Microsoft Azure, you can actually take a calculation service, run it temporarily on some sort of big iron, and then when you don't need that calculation service anymore, you can just spin it down. So as far as infrastructure costs, you are not actually, in your organization, you only are charged for the compute time and resources that you use on that big iron, not for the lifetime of the hardware itself. Okay, so here's a business case for adopting microservices architectures. This could be for any company that is considering going to microservices. So first of all, you can have a more flexible per service licensing model. You can take a microservice and implement licensing just on specific microservices. And if you're not licensed for a microservice, or if a certain user is not licensed for a microservice, then they could just reject the incoming request. You can release new and improved functionality for a specific customer without impacting the rest of the system and other customers. So this is a nice way that we can, so if a customer says we want you to implement a certain service for us, we can do it and release just that service to that particular customer without impacting the rest of our customers. We can devote purpose-fit teams to specific services, and it's easier to adopt a follow-the-clock model of development. So for instance, if you are writing a certain calculation service or a certain pricing service, and you have a specific team that are mainly maybe quants in nature and might not want to get involved in all of the other parts of your application code, then you can just have that one domain fit team working on just that one microservice, and they don't have to be concerned about a lot of the other parts of your system that they're just not going to be working on. And then what we could do is, with a microservice, you can also monitor and fine-tune services at a granular level. So through a microservice, you know that all access to that service are coming in through a single entry point. So it's easier to monitor that entry point to see what consumers are making those requests, and at what time of the day they're making those requests. You could isolate the system hotspots and just deliver improvements just to that microservice. And it's also easy to do canary testing, where you want to release a certain microservice to maybe just 1 or 2 users and see if that works before releasing it to the public in general. Okay, so what do you have to do to migrate to microservices? And this is some of the exercises that Quantifi itself had to go through in order to refactor to microservices. So we want to decide on the lowest level of common functionality that could exist standalone. So for instance, I mentioned some of the services before, like a notification service. We also have things like a log analysis service. We have an authorization or entitlement service, and this is a common code that we could separate out and kind of refactor out to its own microservice. We also have to think carefully about public APIs that we expose, either through REST or through messaging. So some of the interesting decisions you have to make are whether a certain API should be exposed through request response, or whether it should be exposed through pub sub, where basically you could have a lot of different consumers listening for interesting events that come out of a certain request. And then you also have to think carefully about permissions. I mean, you don't want every single user in your system able to access every single function. So you need to design a flexible security model, one that will actually restrict certain microservices or certain APIs within a microservice. You have to implement data models for the payloads, and importantly, for the data models that you implement, you have to make sure that you maintain your interoperability. So not only test them on C# consumers, but for every payload, we also make sure that it's consumable through Java and C++ consumers as well. We have to, we want to make it more flexible by implementing asynchronicity within the code. So we typically want to examine places in the code that are known to have synchronous blocking types of operations and see if we could refactor them into asynchronous patterns. We want to also choose interesting events that could be broadcast from a service to other consumers. So one of the nice things about having a messaging backbone is that certain microservices could broadcast interesting events out to other consumers, kind of in the same way that if you have an old FM radio station, you only get the broadcasts if you actually tune to the station. Well, here what a microservice could do is broadcast interesting events that happen out to other consumers. So that means what's called it implements a push model rather than a pull model. So for instance, you might have a number of services or even applications that are interested to know when a new counterparty has been added to the database. So we could have our counterparty microservice broadcast out messages that lets consumers know about interesting things that happen to counterparties, that maybe a new counterparty was added or a counterparty was deleted or a counterparty changed physical address. So you could examine all of your services and see what kind of interesting events could be emitted from that service. And one thing I also want to mention is that with migrating to microservices, there shouldn't be a rush to take every little piece of code and make it into its own microservice. There could be a risk of reduced performance if you make everything a microservice. So with a microservice, you have the overhead of network communications. You have the overhead of serialization and deserialization between those kinds of common formats like JSON or XML into a native object, whether it be a POCO or a POJO. And if you refactor too much, for some things you actually might experience a decrease in performance. So when you consider the things that you want to extract out into microservices, be very careful. Okay, one of the things that we implemented with microservices is a service registry, and that happens to be one of the cornerstones of microservices. So with a service registry, you could say something like give me a service, or what is the address of a service that will implement incremental XVA. So with that kind of service registry, we could kind of abstract all the other services from knowing the exact physical address or the exact queue name or topic name that another service listens to. Testing, I can't overemphasize testing on the microservices. So what you want to do is kind of Netflix adopted the term chaos testing. With chaos testing, you just want to be able to pull the plugs on various services and see if the system behaves. You want to see if you're able to detect failed services and how long it takes for you to spin up new services and what the other downstream and upstream systems do when you actually have a service that fails. And then you also want to make sure that you stress test the service and make sure that slow consumers do not bring down your service. So for instance, if you have some sort of service that is listening to very fast feeds of equity data, you want to make sure that you have patterns to consume that kind of fast-moving data, and you also want to make sure that a slow consumer won't bring down your other services. One of the things that we found important is developer education. For a lot of legacy developers, messaging and asynchronous processing are huge changes in mindsets, so you have to bring your developers up slowly with that kind of technology. And then eventually you want to consider maybe a container technology like Docker to host your microservices. So a lot of companies are actually starting to investigate things like Docker and just container technology in general. What are some of the challenges that we've seen with microservices? Well, one is functionality creep. So you want to make sure that a microservice is responsible for one domain and one domain only. You don't want to have the temptation for somebody to make a quick fix in a microservice by introducing some other domain that that microservice is not responsible for. So you want to have that functionality creep, and combined with that, you really need strong governance over the entire microservices stack. So you want to make sure that configuration information is consistent among various microservices. You want to make sure that all your microservices have consistent naming of your messaging topics and queues, and as well as things like REST APIs. You want to make sure that data is continually interoperable, and I mentioned that before, that data payload should be consumed by microservices no matter what kind of languages those microservices are written in. You want to make sure that a new version of a message or payload is not going to bring your system down. You don't want to have like for instance, if you have some sort of pricing microservice and you add another field to the data, you don't want to have two pricing microservices hanging around your system, one responsible for one version of the data, one responsible for the other version. So you want to be able to minimize the surface area of your microservices and not have version-specific microservices just to handle one version of a payload or another. Orchestration is always tricky, that with certain microservices you want to follow a specific workflow. So orchestrating microservices just to make sure that you have that the output from one microservice is being handled by another microservice, that's a little bit tricky, and that's an important part of the system, as well as fine-tuning the timeouts between asynchronous calls. You don't want to have a certain consumer wait too short of a time for a certain microservice to be finished. So the whole concept of timing between microservices could be a challenge. And then metrics. So you have to have something that will monitor the usage of your microservices and alert users to potential situations where your microservice architecture could be showing some stress. So at Quantifi, we've built a special dashboard which allows us to monitor the microservice, and I've talked about some of those other microservices that we built, like the notification microservice. So we use that internally. We eat our own dog food, where if something happens with one of our microservices, we actually use the notification microservice in order to alert our users. Okay, and the last slide I have is I want to just show an example architecture. This is the refactored Quantifi microservices platform. So in the upper left, we have the service manager. What the service manager does is it monitors the health of all the various services and knows when a service might be slow, or knows when a service might be down, and when it's time to maybe hot swap in another instance of that service. We have the service registry, which contains kind of the abstraction layer for what services are out there and what services do, and what services respond to certain keywords, and how you could reach a certain service. And then we have the administrator console, which I just mentioned, which allows you to monitor all the microservices and kind of test out the APIs for each of the microservices. On the upper right, we have some of the microservices that Quantifi has. So we have a risk run service, trade workflow service, risk repository service, reporting service, database event publishing service, incremental CVA, and I should also mention incremental XVA service. We have a simulation service, and we have a bunch of other services. In the center is the message bus by which we communicate between all the services and between the clients and the services. So we support both RabbitMQ and ActiveMQ right now. If you wanted something like TIBCO EMS, we could support that also. We also, for all of our microservices, we also have REST interfaces. In the lower left, we have customer-written services. So I mentioned that you could write your own service in any language you want, as long as it interops with our existing services, and put that into the bus as well. We have some real-time data services that handle quotes from various vendors. And we also have, here's our common microservices, so logging, notifications, job scheduling, monitoring, entitlements, a general purpose data access service, and event processing service. Okay, so that is the end of my discussion on microservices, and I think we're going to throw it open to any kind of questions. Okay, so we have a couple of questions out there. We have somebody said, how long was the journey to move to microservices for Quantifi, and what is the implication of the cost base but operating costs before or after? So the journey to microservices, the initial cut took us about 6 months over a small team of developers, and we had a fairly big code base. We had to first come up and write the messaging layer, come up and examine the code, and basically do a lot of refactoring. As far as the implications for the cost base, we really haven't seen much of, to the actual client, we haven't seen a lot of increase in costs. I mean, you could, even though we still have a microservices architecture, or somebody could still run it on their laptop or host the microservices all on one app server. So we have not seen any kind of big change in operating costs right now. Okay, there's a question here. I'm having a little bit of an issue with some of the seeing some of the questions. Bear with me for a second. Okay, are you considering migrating away from a message bus? No, not really. I mean, we found that the asynchronous nature of a message bus really does help us, especially with things like the pub-sub nature. So one of the things is, we do have the RESTful interface, but we consider a message bus to be an essential part, really just to be able to have that kind of pub-sub nature where you can have different microservices listening from events from other microservices, or different consumers listening to events that come out of our microservices. Let's see if I have some other. Okay, hi Mark. What data interchange format do your microservices use to communicate? We support a number of data interchange formats. We support XML, we support JSON, we support native.NET, we also support protobuf and Avro. So we actually have a whole bunch of serializers and deserializers. Okay. Question, do you recommend any particular tool or framework for orchestrating the business processes across microservices? No, I don't. We actually wrote our own. So if you have any ones that are commercial you want us to take a look at, we'd be happy to, but I think that we are we like the fact that we're able to kind of architect our own stuff and write our own stuff, and be responsible for any kind of changes or adding the features. Okay, how many microservices do you have? We probably have around, I'm going to kind of finger in the air approach, around 20 now. But we're always, as things evolve with the platform, we're taking a look at adding some other microservices. I can't mention which ones just yet, but we are going to be expanding that. Okay, let me look for some other users. Okay, so how is session persistence handled by microservices, and is there any special load balancing considerations for deploying across multiple hosts. So as far as session persistence goes, we have some special purpose databases and caches that we use to handle the persistence. And is there any special load balancing considerations? I'm going to have to think about that a little bit and get back to you, Ilya. Okay. Banks have, as you mentioned, monolithic risk platforms. A rip and replace would be impossible. So how would you advise the management to refactor the refactoring of microservice to run in parallel to legacy? So again, this is something that we have done very slowly. We have it's easy just to kind of go to the lowest common denominator. So something that is truly a common service. So you could take something like log analysis or authentication or authorization, and it's fairly data, and make it your first or that service, and make it your very first microservice, just to be able to kind of take something, or even take something that is some sort of monitoring code that you have, and take that and just rip that out, put it into its own microservice, come up with the API around that, and just test that out and see if it still runs. And while you're doing that, you could start to educate your developers on the concept of microservices, on the concept of messaging, or asynchronous processing. Okay. Regarding the number of microservices, you have a single microservice instrument that is priced, or a single pricing service across all instruments. So right now we have a single pricing service, but I know that it's something that we are considering to basically break out the pricing. We haven't made that decision yet. Okay, do you use Redis or any other caching solutions for the Quantifi microservices? Yes, we do. We actually do use Redis. Okay. And I think that is all for the questions. Okay, so what I want to do now is hand it back to Sakvir, who I think is going to make some closing remarks.
Thanks, Mark. Thank you, everyone, for listening in. As I said, the recording of the webinar will be on our website in the coming days. Any questions we haven't been able to answer due to time constraints, we will respond in the next couple of days as well. And thank you, Mark, and thank you, Cubillas, for your participation. Thank you, everyone.